Hello explorers and welcome to another video. Today we are going to install Honcho. And Honcho is a backend service for memory management and keeping memory for different frontends. For instance, I'm using Hermes agent, and that could be stored as a memory agent in Honcho. So you're running Hermes, you're doing conversations, talking and so on, and then all your conversations are sent to Honcho, and Honcho in turn figures out during the from the conversation what is actually worth keeping memory and what is worth informing the agent about in the future, so the agent could be smarter over time. So that is the use case at least. And let's switch over to my screen here. I have a test client that I have just called Honcho test, and I want to install Honcho as a local service. The preferred way that they are talking about on their homepage is installing it as a Docker instance and then doing Docker Compose up and so on. But I want to have it natively installed so I can manage the different services and so on when it comes to resources, and also share databases with other ones and so on, add backups and more. So first up, we have a Debian server. It's totally normal, nothing extra, no extra packages, just a base Debian with SSH and sudo, but nothing more. So let's see that we have it up to date. It's a Trix environment, and it should be up to date and recent. Next up, we want to install a couple of packages. So we want to install Git, because this is a Git repository. We want to install build essentials so we can build packages. This is the GCC compiler and so on. We want to install curl because we will fetch some scripts from the internet to run. We want to install UV. And then we have Postgres, which is the database we will store all the information from our conversations. And then Python 3 VN, because we will run this in a virtual environment. Because some of the Python packages that we want to install is not native Debian packages, or at least the native Debian packages are too old. So we want newer packages that we can run in a virtual environment instead. So we install those as the newer packages from Python, and then the system versions are not conflicting with those packages. So this will take a little while, so I'll get back to you when it's done. And we are back, and now we have installed all the packages. Next up, we want to check the PGLS cluster to see that we have it installed and up and running. And now we can see that it's version 17 main, and it's online, and we also see the different directories where Postgres is installed. So some information about Postgres. And if we run this small command here with a tail and a print and so on, it will pick the first number here, 17, and put into PG version. And that is something we can use in this little script here. So apt-get install Postgres, and then pg vector is what we want to install, and that is to store vector information, and we will use it for looking up particular data in the PG store, the Postgres store, for future references. So if we have a lot of conversations, it's easier to find those conversations with these vectors. So now we need to set up the database. So let's go to the Postgres user. We will use the PSQL interface, and then we will create a user. And this is just for testing. So this is a Honcho user with a Honcho pass. You need, of course, to create a real user with a real password. Don't use this example. And then we will create a Honcho database from that user and put that user as an owner. And then we will connect to the Honcho database. Now we will add this extension of vector. So we have this vector search in our database. We will also grant all privileges to Honcho for this user. So it has all the different, it has access to everything on this database. We will alter the schema to a public owner of the Honcho user. And we will also grant all on that schema to Honcho user. So now the Honcho user is the owner of this system. If we go back, so we still are the Postgres user, we can now run this command here as the Postgres user on the Honcho DB and see that we have this vector extension. And we see now that it's 0.8.0. So now everything should be set up in the database. Next up, we need this UV. So this is the default from their homepage, how to install UV. And UV is this package manager for Python that is helping us installing packages quickly. So we will now put that into our path so we can use it. And if we then run which UV and also the UV version, we can see that we have 0.11.26 is the version. So now a step that you might not need, but because of this limited size of this virtual environment, I only have 20 gig and 2 gigabytes of memory and 2 CPUs. So it's a very limited box, which means that the temp dir is very small, and UV uses the temp directory and downloads so much information and bloats up the machine. So I would need to put my temp directory in my home directory to actually have space. So I will export the temp dir to my home directory and then create that directory. So now we can clone up Honcho. So we will go to our home directory. We are already there. We will git clone depth 1 and then the Honcho git repository. So everything in the Honcho repository here. And if we check, we go into Honcho and check, we should have everything installed. And if we check tags, tag, yeah, we can do git fetch origin and then tags, tags. What I want is to download all the tags so I can see what is available. So here you see all the versions that have been released. I'm currently running on this version 3.11 and I hope there will come a 3.12 soon, because they had a bug where thinking mode for dreaming, which is a way of taking the information you have now and figuring out even more connections between data, and that mode could not use thinking because of a bug, and that was really solved, I think, this week or last week, and I'm not sure if it's in this tag yet, so I'm eagerly awaiting 3.0.12 so that bug have been solved for us. Now we want to use UV sync with link mode copy in order to download all the packages and install everything on our local machine. And we see here that it's going through a bunch of different things, and it says that there is a lot of things that needs to be installed, and it downloads everything in parallel and install packages. So 151 packages are downloaded and installed very quickly, and we even hear my machine in the background spinning up because it's using a bunch of resources on that machine. So hopefully it will not become super loud and annoying during this process. It's just a couple of Python packages. There we go. Now all the packages are installed, and next up I want to set up a DB connection URI as an environment variable. So this is something I use just during the installation step here. So we say that we have this Postgres, and then we use scicog and with our user and our password at localhost and the database of Honcho. And after we've done that, we can do this uv run umbilic upgrade head. And this is database migrations for Honcho. So we will get the Honcho database up to the state where it is now. And I think this is something you can run every time you do an upgrade, or every time you do an install or change version and so on, so you have the latest database schema in your database. So this will take a little while to run through, so I'll get back to you when it's done. And now the migrations are done, and now we need to configure the .env file, and this is the environment file with all the environment flags for Honcho. And I will copy paste in the full file and then talk about everything that needs to be in this file. If we start from the top, we have this connection URI, and this is what we saw earlier, so that is needed, of course. Then we say that the auth for this particular Honcho is no, don't use authentication at this moment. And of course, if you want to set this up in an environment that isn't or is hostile in any way, or is not your local environment, then you of course need to set up authentication. In my case, I'm running it in my home lab, so authentication is not super important. I don't need Sentry. Sentry is a logging platform, and I'm not using it. Telemetry, it does need to send telemetry back to the Honcho people. And embedded messages is when you have this vector database that we were talking about. For every time you send in a new chat log, it will go through and for every message create embeddings, so it will be faster to find a complete message in the database. And for my use cases here, when we want to derive information, we want it to learn about my way of working and so on, the actual message database or the actual conversations are not super important, and I don't need quick answers there. If you need, for instance, to ask, what did I say 6 months ago, then this could be interesting to actually find a particular message, but other than that, not at all. So then we have the routing for our local LLM. So you have set up Olama somewhere. In my case, I've set it up on one of my nodes in my cluster here. So wherever you put it in, you set it up there. Next up, we will talk about the deriver model. And here it's fine to use any model that is fairly quick, because this is also run frequently during the conversation with the server. So when you send in a conversation log, it will go through and derive facts from that. And Quen 3.59 billion would be just fine. In my case, I have actually trained my own model as deriver that comes from a Quen 3 8 billion parameters. And I think I will do a video talking about how I created this model. But this is a particular use case. And I also read up that the summary model could be something that you can train as well. The main thing with this deriver is that you train it in order to give the right schema out. It needs to answer in a particular way. And if you train a model, it will be quicker and more it will hone in on what it actually need to answer every time. It will be better on that case. Then we have the summary model. This is when you need to summarize whatever you have been talking about. So session summaries pretty much. And then we have dialectic levels, and this is reasoning depth. So when it comes to this, we have a bunch of different models here. So when you have sent in a log, we will derive different facts, we will do summaries, and then when we call on the model to get information back, it will use some of these levels in order to get the actual information that is potent back to you in order to give you a good answer. And depending on how much it should think and how long time it should take, we have a couple of different models here. So I've used a Quen 3.5 billion if we do minimal reasoning, and then a 9 billion if we do low reasoning. And then, just so I don't use too much memory on my card, I have been using the same model for medium, high, and max, which means that it doesn't need to load in a separate model for any of these levels. And when it comes to dreaming, when it needs to find inductions and deductions, so observations and representations of your chat logs and the actual derived facts, this is something that is run every 8 hours or so, something that runs in the background. So here you can have a more capable model because it doesn't really impact your when you talk to the model. So something more feasible here would be 3.6, 27 billion. I think this is the probably most capable model that is out today, so that's why I'm using it. It's a dense model. If we go for the Quen 3.6 32 billion models, that is a model with a mixture of experts with only 3 billion parameters activated at a time. This will activate all 27 billion at the same time. And then we have some host binding here for the host. We say that anyone can connect to this one, and we want it to be on 8,000. So a pretty simple setup there. Next up, when we have done that, we want to check that everything is working. So we will export this DB connection URL again, and then we will run UV with Python 3, and then we will load the source configuration, import settings, and then print that the configuration is okay and what the deriver model is, just so we see that everything is configured, and we see that I got my particular deriver model out here. Now I want to set up some couple of services so I know that this will be running whenever I restart the machine. So we will create a Honcho API service. This is what will be called by Hermes or whatever agent you are using. And it's pretty much setting up the Honcho fast API after we have a network and after we have the Postgres database running. It's a simple service. We will run it with my current user and in the work directory of my current user and the environment file that we created earlier. And the start will be in this local bin UV. We will run fast API and then the source main Python and port 8000 so we get it up and running. Restart on failure, restart after 5 seconds, and it's a multi-user target. And when we have stored that file, we will go through and create the deriver service as well. And it's not much different. We want the API service to be running and the Postgres service. And then the local here is that we run UV, run Python with the module source deriver. And then everything else is the same as before. So now we should have two services configured and done. Now we need to do system control, daemon reload, and then we will enable our services so they will start on boot, and then we can start the first API service and we can start the deriver service. If we then do a system list unit, no legend, and then grep for Honcho, we can see that both of them are running. And we can also do a quick check with journal, unit, Honcho API service. And let's see if we get any information there. And we can do the same for the deriver. Let's see if they are started. Status. And we can see that it's starting now. It could take a little while, especially when you have very a lot less of the CPUs and other resources locally. There we can see that the API is up and running, and if we check the deriver, we can see that it also did start up here and also started the scheduler for the deriver. And we can then do a health check a little bit quickly here. Check that the health is okay, status okay, and the documentation, if we want, we can also find that over at docs, and that is the API documentation. So this is a Swagger document. So if you want to run this, of course, you should open it up in your web browser in order to look at that. So now we have a Honcho server up and running, and we can just run Hermes Memory setup and then choose Honcho and then say that this is the host that we are hosting Honcho on, and then in case of Hermes it will start using Honcho as its memory provider. So all the conversation logs will be sent to your local Honcho, and it will derive different facts from your conversation logs, summarize them, and then do a dialectic search in order to respond back with who are you, who are your agent, and information about how you work together and so on, in order to improve the workflow of your agent. So this was what I wanted to cover today. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you have any comments or suggestions, leave those in the comment section down below. And I really want to see you in the next video.